Well, good morning, sixth grade. Today we're going to start learning about probably my favorite of the three laws, of Newton's three laws, and that is Newton's third law of motion. This one's probably the easiest of the three to understand because we do these things every day and we see it happening, and I think it'll be a lot easier for you guys to understand this. So Newton's third law of motion basically says, we call this the law of action-reaction. Now, this isn't like a cause and effect like in language arts. For instance, if I was to hit my finger with a hammer, what would my reaction be? Well, it'd be to shout. Well, there was a cause and then an effect. Newton's third law is not necessarily that way. It is about an action and a reaction. So, for instance, if I have two marbles and I roll them towards each other, there's an action there, right? I rolled them towards each other. What's going to happen when they hit? They'll bounce off of each other. There's a reaction to the action that's been taken. So we're going to be looking at several examples of Newton's third law, real life examples, and then we'll go through what exactly is happening with each of those. And then you'll have some questions at the bottom of this video underneath on my webpage that you'll have to answer, and then email those answers to me for your daily credit. Okay? All right, so Newton's third law, again, we call it the law of action and reaction. It means that all forces come in pairs. When one object puts a force on another object, the second object reacts by putting an equal force back onto the first object. So I have some examples over here of force, of action, reaction. Let's look at some of these and let's see if you can figure it out. If I want to fly, watching a bird fly, what motion do they have to do in order to fly up into the air? What are their wings doing? Yeah, their wings are having to push down in order to go what direction? Up. So if we look at what is happening here, there's an opposite reaction that's happening. So let's look at this next example here. If I have a person paddling in a kayak, and they're pushing their paddle backwards against the water reacts by pushing the boat forward. The boat moves in the opposite direction of the force of that paddle. So in order to push, to move forward, I have to pull the water backwards. My movement is opposite. Okay, so Newton's third law again talks about how there's an equal and opposite reaction. So again, if we go back to Newton's law, third law says for every action there is an equal and opposite reaction. By pushing the wings down, the bird can fly up. What about this rocket ship? The rocket ship, how is it able to move up into the air? Yeah, it has to shoot flames and its energy downwards in order to get the rocket to move up. All right, let's look at our next example. So we talked about our paddling backwards in order to move the boat forward. Also, if I sit in a chair that has wheels on it and I push against my desk, like my rolling chair, and I push against the desk, it's going to send me backwards. This is where I would normally sit in my rolling chair and push it backwards or push forward so I can go backwards, just to kind of give you an example, but you get the point. Here we go. You ever ridden in bumper cars at an amusement park? Then you felt Newton's third law of motion. As you bump into another car, the other cars bump you back with the equal amount of force. And then finally, again, here's the example of the rockets. Rockets will ascend because of Newton's third law. It means they go up in the air. So as the rocket expels or gets rid of the gases pushing downward, that equal and opposite reaction occurs. The gases put on a force that causes the rocket to move upwards. So let's look at some real life examples of Newton's third law in action. I'm going to be giving you guys some examples tomorrow as well, but I'm just going to show you a couple of quick examples of Newton's third law. Maybe. All right, so let's look at this. We have our Newton's third law of motion. For every action, there is an equal and opposite reaction. So in order for this person to do a kickflip, they first have to push down in order to get that skateboard to pop up. So it's opposite reactions. In order for this plane to fly forward, it has to be pushing backwards or shooting its fuel backwards. Look at these old ladies here. I'm sorry, elderly ladies, as they are pulling that water backwards, it helps their canoe go forward. Opposite reactions. Bouncing a basketball or bouncing any ball, in order for that basketball to bounce, we have to push it downwards so that the opposite reaction is the floor pushing back up on it. Look at these jellyfish. The jellyfish are moving their bodies backwards and expelling water behind them in order to move forward. Perfect example of Newton's third law in the ocean. Jumping on a trampoline, same thing. Our body bounces down and that trampoline pushes us back upwards. So there's opposite reactions there. Going as we fall down and bounce down, the force from the trampoline pushes us back up. Dropping these weird looking water balloons. These water balloons, as they fall down, they are bounced back up. In order for them to bounce back up, there has to be some sort of force pushing them up. Let's think of another example that we use all the time, walking. We wouldn't be able to walk unless Newton's third law was put into motion. In order for us to go forward, our foot is pushing backwards. Think about it. I want everyone to get up and take a couple steps, and I want you to think about the direction that your foot is going in order to get you to go forward. It's pushing backwards. What could work against you when it comes to Newton's third law? It has to do with working against inertia. If the floor was slippery, what would that be? What would be happening? Yeah, friction kind of plays into effect with that. Another couple of examples. What would happen if I exerted pressure on a chair by sitting on it? I sit in the chair, okay? But let's say that the chair did not give the same amount of force back up towards my rear end. What would happen to me? Yeah, I'd probably fall down. The chair would collapse and I would fall down. If the floor wasn't pushing back up against our feet, we would not be able to achieve walking. Therefore, we wouldn't be able to achieve Newton's third law. Sitting in a chair, if that chair didn't put the same amount of force back towards our body as we are as we're sitting, the chair would break. What about, let me see, shooting a gun? Any of you guys ever shoot a gun before? Especially a bigger gun, or any type of gun, really. I go to put that gun against my shoulder, but I don't have it against my shoulder, and I pull the trigger. What happens to the gun? It shoots backwards as the bullet is going forward. So that would be another example of Newton's third law. What I want you to do for your assignment today, again, there's questions underneath this, and I want you to answer them and send them back to me. You can write them out and take a picture of it, or you can just type them up in an email and email it to me. Tomorrow we'll look at some more examples of Newton's third law.